Hey guys, Mr. Bowman here. Today's learning objective is on the left. We are learning to identify the features of square root graphs, and I've got some notes there that will assist us with our understanding. Our general formula is y equals a, that is multiplied by x plus b square rooted, and we're going to then add c to that as well. And very similar themes to our other graphs. The a is going to make it skinnier or fatter, and I'll show how that one is slightly different. The B, that's going to move it left or right, and the C, that's going to move it up or down. And I've got some other notes that I wanted to emphasize, and I'll connect them to the pictures or the graphs that we're just about to draw. Square roots, I like to call them sideways parabolas, and you'll see what that means. And typically, you can't have negative square roots. So you'll see that there'll be no negative values within our graphs as well. And that does impact the domain and the ranges of our graph. So let's have a look at the generic graph. So y is equal to the square root of x, and hopefully you see what I mean when I say it looks like a sideways parabola, because if that carried on into the negative range, that would look like a parabola, but it's just been turned on its side. And you'll also be able to see that there are no negative values, and that's because no number will ever result, the square root of a number will never result in a negative y value. So we've got those no negatives. They will, or they may end up being complex or real answers. Sorry, complex or imaginary answers, but we're really looking at the real numbers here. Okay, so just like parabolas or any other shape, we can move them sideways, left and right. So if I do -1, that should take it to +1. And if I do +2, that should take it to -2, which it's done there. There you go. So that B moves it left or right using the negative values. We should be able to move it up and down as well. So let's go add 3. So there we go. It's moved up to 3. And let's -5. And we can see that shifted all the way down to 5 as well. And the final one to note is the A value. So the A is different. It's actually the opposite of a parabola. So for a parabola, a number greater than 1 is going to make it skinnier. In our case, it's going to make it wider. So let's have a look at that. 3. There you go. You can see it's made it a lot fatter, a lot wider, opposite to a parabola. And let's say I made that 0.5, or you can see how that's been made a bit skinnier now. And we'll just compare them all side by side. So there's 3, and there's our standard parabola. So we can see the green one, that's a lot wider, and the light blue one, well, that's a lot flatter or a lot skinnier. And the purple one being our normal x, square root of x graph. So we've looked at A, we've looked at B, we've looked at C, and we can combine all of them. So let's have a look at the square root of x. Let's say we want to make that wider, so let's times that by 4. That's really wide now. Let's say we want to move that down to -7, so we're going to go -7. And let's say I want to move that across to +5, so I'm going to do -5. So like that, we can combine all of the events, or all of the A, B, and C to move around our graph as we need to. So hopefully you found the video, or the first half of this video on the features of square root graphs useful. What I suggest you do is please pause the video, get those key notes, key points down. Do have an example drawn in your books. And I'm going to pause this video. We're going to switch back to PowerPoint, and we're going to figure out how to come up with the equation of a given square root graph. Hey guys, and we're back. We've got our new learning objective. We are learning to determine the equation of a given square root graph, and I've got a given square root graph here. So first step, let's write our general formula. So y is equal to a, the square root of x plus b plus c. And I'm just going to change pen color. Let's move on to the orange pen, and we're going to use our reference point. So our default graph should be at 0, 0. So that means it's been moved across to +2. And that means that b value should be -2. So that's our first step. We then want to look at how much it's been moved up. So it's been moved up 1, 2, 3, and that's been moved up to +3. And that means our c value should be +3. And that gives us 2 values. We can then use another point, and we've been given that, 6, 4. to mathematically solve what the a would be. So let's write down our generic formula again. So y is equal to a, the square root of x plus b, and we're going to add c to that. And we already know that our b value, well, that's going to be -2, and our c value, that is +3. And we also have a given coordinate, 6, 4, and at that point, x is equal to 4, x is equal to 6, and y is equal to 4. We're going to put those two numbers into our equation. So 4 is going to be equal to a times 6 times the square root of 6 minus 2 plus 3. 4 is going to be equal to a, the square root of 4 plus 3. And then 4 is going to be equal to 2a plus 3. And I do want to note here, we do want to ignore the -2 answer of that square root, because per our graph, we can't really deal with negative numbers for this graph. We then want to mathematically solve this, so that 3 becomes -3, which is 1. And we're going to go a is equal to 1 divided by 2, or 1/2. And that means we've solved our equation. Y is going to be equal to 1/2 of the square root of x minus 2 plus 3. Hopefully you found this short video on the first half, which was the features of square root graphs, and the second half on determining the equation of a given square root graph useful. Now let's pause, make sure you get the example down, make sure you got the notes from the first half down, then let's get into some questions.